So welcome to everyone who's joined. When we started discussing a productive kind of webinar that most people may need that have a water well, landing on the top five things that might kill a well, or specifically the pumping equipment, seems like a real logical place to start. So let me make a little bit of an introduction of myself, and then we'll cover the five things that can, as Alex said, be very costly and to well owners that either damages equipment or can actually damage a well. So let me move forward. Can you see my screen, Alex?
Yes, sir. We are good to go.
All right. So a little bit about me. I am a licensed well driller in the state of Texas. Also, the agency that governs our licensing. I'm a subject matter expert for TDLR. I've been on their advisory council now for a couple of years. I own and operate Barco Well Service out of Fort Worth, Texas. We have 27 full-time employees. We manage somewhere, we think, in the neighborhood of about 6,000 wells, give or take. We founded Resource Monitor back in 2021 when we saw the need to be able to remotely monitor and manage some of our well customers' water assets. Since then, Resource Monitor is now in 7 states. We're approaching 2.4 billion gallons total through our meters under our management program, and that garnered the attention of my local groundwater conservation district, which is 4 counties. It's also the busiest one in Texas as far as new well permits issued for the last 3 years in a row. And then also, I'm an educator for the National Groundwater Association and also the Texas Groundwater Association for license holders, both nationally and in the state of Texas. So let's talk five things that'll kill a water well or the pumping equipment. Um, the first place to start is probably the most logical, which is drawdown, because we are seeing drawdown in almost every aquifer in the US, and we'll talk about what that is. Then power issues, then rapid cycling, mineralization number four, and then coming in last is deadhead, which is not moving water when it should be. And so we're going to move through these kind of quickly. Drawdown happens when, as you can see in the graphic there on the right, there is a dotted blue line where the original water table was, and then you have two wells down into the productive zone where they're pulling water from the ground. And you can see the deeper of the two wells, presumably with a higher flow rate, has created this cone of depression, and that is the actual inclination of the water moving through the formation to get to a well. And if wells are close to each other, or if a well is drawing more than what the formation can produce right there locally or regionally, or in a very large aquifer like the Ogallala, if the total water in the aquifer has been drawn down, then you can see these conditions. As I stated, there's 27 major aquifers in the U.S. 13 of the 27 are in managed depletion. It can cause some very bad things when you get to the point of drawing a well, drawing the water in a well all the way down to the pumping equipment. It causes cavitation. Think running dry. And this would be like if you were in your car and you put it in neutral and just mashed the accelerator all the way down. It's not going to go anywhere, but it sure does blow things up pretty quick. Dry run conditions are very bad for pumping equipment as well, not just the motors, but the pumping equipment uses the fluid moving through it to keep it cool. So when you do start pulling air in, you can do a couple of things. You can start intermittently loading and unloading a motor. You can also run a pump dry, which causes a lot of friction and heat. And then you can also, if when you draw a well down or you're not moving any water, you're not moving any water across the motor itself to dissipate the heat coming from the electric motor. So that's a bad plan. And then when you draw a well down, you can actually cause particles in the formation to move around and even collapse. We've seen some places in the US where there's a phenomenon called subsidence. And subsidence is where an aquifer has been drawn down or a formation has been drawn down and the formation collapses, but then it seals off where it can't rehydrate, if you will, even if the aquifer recovered. What that means is that the ground level is actually sinking. So drawdown happens. It's very bad for pumping equipment. Sometimes it can cause even more problems in the aquifer, and it's something that you can manage by how much water you're pulling out of the aquifer, either in total or locally from a single well. And I'll talk more about that. And it's probably an issue that well owners would want to discuss with their contractor. The symptoms of drawdown would be uh, intermittent production, and we see it most frequently in a shallow well or a well where the pump is trying to pump more than what the well will produce. And people say my sprinkler heads are spitting, and they'll run at full strength for a few seconds or a minute, and then they drop down. And that's when the pump is actually pulling air in, and then they'll come back here in a few minutes and they'll pump at full strength for a little bit. Drawdown also occurs if you're on a big irrigation well or on a commercial well, something that's pouring into a surface water tank or a pond. Then you'll see bubbles as a well approaches drawdown. Those bubbles are bad for everything because, again, air moving through a water system is a bad plan. We can see the next slide here. This is actually a well where, if you'll notice from left to right, you can see the production level dropping off in this well pretty steadily from the beginning of August. And then there was a day on the 16th, they shut it down for a few minutes or had a power outage. It came back on very quickly, but even after it rested for a little while, you just see the production level continue down. Then we set a low flow alert through our app at Resource Monitor. And when it reached the low flow alert, we had the owner go turn the well off because it was calling for more water, or the pumping equipment was capable of producing more water than the well would give up, essentially. So we shut it down, uh, took some measurements, ended up having to lower this pump another 200 feet into the well and upsize the horsepower. But they caught it before it trashed the whole system, and we were able to reuse some of the components whenever we did alter the pumping system that was in the well.
Hey, Jason, can you talk about too the issue with kind of wells that are too close to each other, where we've seen instances where someone's production is perfectly fine, but then the guy over the fence line turns on their irrigation well, their center pivot, or whatever have you, and all of a sudden their consumption of water drastically affects your own capability to get your own water, and how that can be a real challenge.
Sure. We call it interaction. When wells start to communicate, that is, again, another situation where a drawdown is the issue, but it may not be drawdown in an aquifer for an entire region. It may be that they've drawn the water out of the formation in a localized area and created this cone of depression around both wells. You can kind of see this V formation around the larger of the two. When those two V's cross each other, then you have well interaction, and you're fighting over the same amount of water. The water then is not moving through the native material in the formation as fast as you're pulling it out. And the further that you extend that cone of depression, the flatter the angle of the water moving through the formation becomes, and slows the water down. We've even seen in some cases where a well was drawing down, whether it was too many in the same area or just the regional drawdown in the aquifer, but they were able to actually produce more water from a well by shutting it down for 2 hours a day. They produced more in 22 hours than they could in 24 hours because that angle of inclination got so flat and the speed of the water moving through the formation was slow. So interaction between wells, whether they're at different depths like these two in the graphic, or whether at the same depth and they're just creating such a large cone of depression, it is a very bad situation. And in essence, both well owners will suffer on account of it. So uh, hopefully that answers what your question was, Alex.
Yeah, totally.
We saw that in a couple of water wells that we're monitoring out in West Texas in the oil production sector, where every time someone turned a well on around them, then you could see the production drop off. And they weren't fully engaged as far as their cone of depressions were overlapping, but certainly you could see that the production was dropping off because of interaction between the wells. So on to the second thing that is predominant in killing pumps and motors and wells are power issues. Power issues, you don't always know you're having a power issue until sometimes it's too late. But there are a lot of situations where we've been monitoring wells and equipment and we caught a power issue before it did, in fact, destroy the equipment in a well. Those issues can be an unbalanced power situation. This happens a lot with three phase, where in three phase power, you have three hot legs, if you will. All three of those oppose each other. And that's how you get your three phases. Well, if one of those legs of power gets out of balance, whether it is related to the seasons, sometimes in the really hot weather down in the south, we have power unbalance because of the HVAC load on the grid. Sometimes during cold weather, you'll see the same thing. But what happens is one leg gets out of balance, and that in turn causes the windings inside of a motor to get out of balance as far as their effort. And then you get a vibration. Someone once told me it'll make a motor shake like a washing machine on spin cycle. Certainly not ideal for making equipment last as long as it can. And then a dropped leg. This would be a little, or could be also related to homeowners that have a residential well where the well runs on 240-volt electricity. That's 220-volt opposing legs. You can drop one of those legs, uh, go into a well, and you may not notice it in the house because most everything else in a home runs on 120 volts. Well, if the wrong leg dropped, the well might not operate, or it would try to single phase, and in turn damage the well equipment. And you may not necessarily know that's what was going on in the home. Phase reversal is another issue that happens with power companies sometimes, whether they're bringing on new facilities or they have to change out old transformers, things like that. Sometimes when they bring the power back on, the phases are not in the same order that they were before. And if a three-phase motor has three legs in a certain sequence and you reverse those three legs, you can actually make a three-phase motor run backwards. We had this happen recently with a municipal or a rural water system where a new transformer went in an area. They had them offline for about 4 or 5 hours while they changed the transformer out. It came back on, and the well equipment was then running in reverse. We saw a 60% reduction in output. Alerted the owners or the water supply corporation that we saw that, and they were able to go correct the phase reversal to that equipment before it did any damage. And then surges. Surges are another issue with water wells. Typically, water wells are a really, really good ground. And what I mean by that is the grid is all relating to being grounded to the earth. And there is no other better ground than a water well, which is either plastic or metal casing cemented into the earth down to the water bearing formation. I mean, it literally is the best ground in a lot of areas. If you have a PVC cased well, the groundwater that goes to the pump, the bottom of the pump in the bottom of the well, that is a fantastic ground. And so sometimes surges seek out water wells. Sometimes we see minor surges and we have little burnt parts of a variable frequency controller. And sometimes I've seen controllers be blown off of the wall in a well house and everything around it be completely burned up. So surges hard to protect from, hard to predict, but certainly something that people need to be aware of, that it could be one of the causes for well equipment failures. And then we've had wells fail because they were hit by lightning, quote unquote, hit by lightning. And where the surge decided to exit the pumping equipment, it blew a hole in the side of the casing and rendered the well then inoperative because the filter pack material was coming into the well. So something to be aware of. Another issue that we see from time to time are loose connections. Loose connections create a lot of heat, which is the enemy of electric motors and pretty much anything on an electrical system. But what that amounts to, heat is generated when the same amount of energy is trying to pass through either a very small contact surface area or a pinch point, if you will. You can see in the bottom right picture there, that was probably a loose connection on a wall plug, and the load created heat. The heat started melting things that that the plug is made out of. And then you're into this degrading cycle of, well, now something's melting and now you've lost insulation. Now it's getting hotter until you get to the point of either a breaker tripping, or if a breaker doesn't trip when it's supposed to, you can wind up with something that looks like that picture on the lower right. Symptoms that you may see in your well equipment from power issues: low flow from a pump. This would be, if you dropped a leg or a pump was not running on the appropriate power, you had a brownout issue, something of that nature. You may see the pump controller faulting out, which this is what we would hope happens. The pump controller has some sort of safety measure in it to either drop it out based on voltage or amperage or some other adverse condition that it's observing. If you have um, a pump come on and you can visibly see the lights in the house or the lights in a building dim, and they didn't used to do that, that's sometimes an indication of a loose connection or a load issue. You'll see breakers tripping, obviously, and then overload devices in well controllers and equipment. If the overloads pop on a well controller or control box, there's usually something going on, and you may get it to reset, and you may not. If it doesn't reset, that usually means there's a bigger problem with the equipment. But if it popped at some point, may want to take a look at what's going on, and don't just keep resetting the overloads until nothing happens and then it's Sunday afternoon. You have to call your well contractor to come help. So power issues. Next, or there's actually a really good picture of a three-phase controller that we were called out for, and you can see over here on the right hand side that first phase that's coming into the top of the three-phase breaker. It didn't quite get clipped in as tight as it needed to on install, and you can see that the wire has now become visible. That's not good. And then if you look up that black wire, you can see that it has melted the insulation all the way back, maybe 6 or 8 inches up that conductor. Bad situation. But on the left-hand side, we can see this in our monitoring system where presumably there was a signal to the pump that told it to kick on and start producing water. Pump tries to kick on, but at every one of these intervals, it hit the overloads and it kicked it right back off. When you see a regular pattern like this in a well system, that is generally the result of power or mechanical issue that's causing overloads. And so we were able to catch this before it went on for days and days, make the repair for the customer, and then they're back in business, having bought 4 feet of wire to go in that panel instead of a 100 horse pump and motor that's 1,300 feet underground. So again, catching these issues early can mean the difference in very costly repairs or even damage to the well itself. So um, next on the list is rapid cycling. And rapid cycling is kind of an interesting concept when people think, well, if it's turning on and off, what's the big deal? The big deal for rapid cycling is that a motor in a well, when it starts, it takes a tremendous amount of electricity to get that motor moving in the direction that it needs to produce power or produce effort to turn a pump. That inrush of electricity, if it's a single phase or a three-phase hard start, is a load that it needs to run for several minutes for the water that's around the motor and the pump to pass by that motor and cool the motor back off. Rapid starts or frequent starts, rapid cycling, uh, all those things yield a buildup of heat in the insulated coils, or I'm sorry, insulated windings in a motor. And heat is the enemy. Heat breaks down insulation between those wires that generate the electric field or magnetic field in an electric motor that cause it to turn in a direction. Things that can cause rapid cycling: a bouncing float switch. So if you see here in the background, this is about a 4 or 5 acre pond that is serviced by this well down here in the bottom left. And there's a float control on the edge of this pond that sends a signal to the controller here, this white box right next to the well, sends a signal to it. And if that signal were not filtered through that controller, then you can get wave action on the pond, whether it's a cold front blowing through, or sometimes fountains will get in sync just enough with the waves and the wind to create wave action that causes a float switch to bounce. Bouncing float switches, if it is sending a signal and it's causing a pump to start, stop, start, stop, start, stop, that is a very short lifespan will that the pump and motor will see uh, due to that. Now, in this case, this is a variable frequency controller, so that means it doesn't start every time the float switch kicks on. It goes through a startup cycle where it kicks up to a less than maximum speed on the hertz, and then it eases into the full load. But it also has a delay on the incoming side so that we don't have to worry about float switches bouncing or the float switch in that pond bouncing, causing the controller to kick on and off. There are several other ways to control a delay on startup for bigger motors. Um, on a residential system, float switch is not going to be an issue unless you have a storage tank, but you can have faulty controls like a pressure switch that closes when the well system sees low pressure and it opens when it gets to its shutoff pressure. We've seen tampering on some of these. Maybe a spring is wearing out and you'll get a close, open, close, open, close, open on a pressure switch. Again, same idea, the inrush of current into that motor and the start stop is a very bad situation for the pump and motor, and it won't last very long when it does that. Probably more common than a pressure switch failure is a pressure tank failure. And if no one really has ever explained it, I'll take the time to do it real quick. A pressure tank on a well system is there to store pressure and volume to extend the period of time in between starts for a pump and motor. So think stored pressure and volume, a savings account, if you will. And when you extend the times in between motor starts, you're extending the lifespan of a pump and motor. Motor starts essentially are like miles on a car. The more times it starts and stops, the more miles are on that. Someone used the analogy one time that if they built a brand new house and they put a ceiling fan in the house and they just turned it on and left it on, how long would the ceiling fan last? Maybe 20 years. But if you have a 6-year old over there flipping the switch on and off, on and off, on and off 250 times a day, the motor's not going to last as long because it goes from full stop to trying to run at 3,600 RPMs, or with a ceiling fan, it'd be slower. But on a well pump, it goes from a dead stop to 3,600 RPMs in the span of like a hundredth of a second. So it's a very violent reaction whenever you turn a motor on and off. When you have a bad pressure tank, then you lose your stored pressure and volume in the tank to extend in between times that a well needs to start. And so what normally happens is you have either a water and air combination tank, or you have a captive air bladder tank, and one of two things happens. Either the air volume related to the water volume gets out of balance, or that bladder perforates, causing you to have no stored pressure and volume. You may have a full pressure tank full of water, but there's no buffer there where the air is actually your expansion mechanism in the tank. And so you'll hear rapid cycling. And this will usually, if you're standing next to the equipment, you'll hear it click, 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 click. If you're in the house or you're using a garden hose or in the shower, what you'll notice is you'll get a hard surge or a bounce in pressure, and then it'll drop back to almost none, and then a hard surge, and then it drops back to almost none. Very bad situation for well equipment. If you see surges or rapid cycles like that, then that's time to step in, intervene, turn the power off, call a well contractor, do something, or it's very, very quickly going to cost you more than it may have been able to cost you more than if you'd been able to save it. Low flow and leaks is also another bad situation to put pumps and motors in. I've got a graphic of that. This is on a 740-foot water well with a 5 horsepower single phase pump and motor. There's a picture of the equipment there on the right. The irrigation contractor was going to tie into this with a mechanism to keep the well from cycling too frequently, which is always a good plan if you're running a straight irrigation well. But as we see over here in the graphic, they can run zones from midnight through about 2 o'clock in the afternoon. They were watering something. Maybe this was when it was brand new and they were watering and saw it, and then it's supposed to shut off, but it actually never shuts off. And these um, lower volume bars here on the right side of the graph, water's moving, and that pump and motor is having to kick on and then kick off rapidly because it's not enough water to keep it running, but yet it's enough to keep cycling because of the size of the small pressure tank. We got with them, found out where the leak was. They corrected it. We go back to running up here in the acceptable zone where that pump and motor were designed. So leaks can be a killer as well. Fourth thing that a lot of people in a lot of parts of the U.S. deal with is mineralization. Iron is probably the single most prevalent mineral in groundwater. All groundwater has minerals in it of some kind. They can be iron, it can be calcium, manganese. We see some combinations of those. We can even see biological materials, biofilm or slime, bacterial colonies, things that grow on different minerals in the well and produce uh, substances that plug up the intake of a pump and motor. This is a residential size pump and motor here on the top left. And you can see the one on the left has been in the well for a period of time, and the one on the right is a brand new one. What you don't really see is the openings where the water is supposed to go into the pump right here. And they're completely clogged with iron scale and bacteria. In this pump, that's probably why it failed and why they had to put a new one on. Same issue on this pump on the right. This is a bigger industrial pump. They've got iron intrusion, or they've got iron scale buildup, and then they have some kind of other intrusion that looks like maybe biological in the well that's caused the intakes to be completely blocked here. What that would look like if you were observing it on our program is this graphic here on the bottom. This is, in fact, a well that has iron scale buildup pretty badly. This well runs about 45 days in between rehabilitation treatments. And you can see when it starts off after a rehab, it's max production, probably 12 gallons a minute, 11 and a half to 12. And then you see as it drops off, it starts down in production pretty quickly. What happens, especially in wells that have a heavy iron content, is when you draw the water down, you've exposed a bunch of that mineralized iron to oxygen because it's evacuated the water out of the well. We all know what happens if metal and water and air converge, you get rust, and that's why this mineralization on both of these pumps looks like a rusty, piece of metal, is because that is the same thing that happens to rust, or same thing happens to metal above ground can happen to the iron in a water well. And you see back to the graphic here where it drops down to less than a third of production of what it is when it's clean. We get a low flow alert on this particular well to go out and do a chemical rehab on it. You see a partial day here where we disconnected um, the meter from the well to do the chemical rehab, and then we got part of a day, and then the next day it's back up to max production. But even in the first 10 days here, you can see after a rehab, it still starts dropping off, and that's a result of this kind of substance here growing on the intake and the screens and parts of the well that need to be cleaned out periodically. So mineralization, naturally occurring stuff in the groundwater that blocks the intake of pumps and motors. It can also insulate the motors to the point that the motor doesn't pass any water over it to cool it. So in both cases, if you run dry, back to what we talked about initially, cavitation, essentially, if it runs dry, it's not moving any water, bad for the pumping equipment and also bad for the motor that drives it. So mineralization. And the last one is deadhead. Deadhead happens when a pump is running, but no water is moving through the system. And this can happen due to ice. As you can see in this picture, this is a well that we drilled over in Dallas, Texas. 1,300-foot well, pump was hanging somewhere just over 1,000 feet. We had an extended cold period, and the equipment, as you can see the big controller in the background, uh, it called for water, but the wellhead had not been properly insulated. And so the cold obviously yielded an ice plug. I I don't know that I could come up with a better picture than this, where we unhooked the wellhead or unscrewed the plumbing off of the wellhead and the ice stayed intact. So ice causes deadhead, closed valves cause deadhead, faulty controls. Sometimes we'll have a contactor or something in the control mechanism that sticks. That can cause deadhead where the mechanism to close the points to make the well run melts together and it can't open back up. Well, then it's going to keep sending water, and if there's nowhere for the water to go, you end up with deadhead. We've also seen manual override on controls where someone puts a well in manual mode and it overrides any pressure sensors that would call for the well to come on, and it ends up in a deadhead situation. Hopefully, at this point, it blows one of the pressure relief valves in the system or hits another safety mechanism, overpressure alert, something in the controller to shut it off before it blows the pump and motor up. And then a faulty install. We followed some homeowners that tried to do repairs for themselves, and they ended up taking two control wires that were supposed to be broken by a switch or a contactor, and they would put them under the same screw on the pressure switch and tighten it down. And then when they throw the breaker on, the well comes on, and they thought they had it figured out. About 3 days later, they called and said, "Hey, I put a new pump and motor on or a new pressure switch, and something's wrong. It won't come on." They had actually wired it in so that the motor was going to run continuously with no controls. In one case, it created so much heat in the water that the PVC pipe the pump hangs from melted, blew the pump off the end of the column pipe, and was nowhere to be found. It was in the very bottom of the well. And so faulty install sometimes comes back around and ends up costing more than what it would if a licensed contractor had actually performed the repairs. So deadhead, no water moving, and you've got effort from the pump trying to move water. Troubleshooting, uh, things to look for. The 5 pitfalls we talked about, how to detect those. The easiest thing I can tell to look for is if a well owner sees changes. Um, if flow changes, if the sound the well makes changes, if the lights flicker more when you're trying to wash dishes or running the dishwasher than they normally do, if you have changes in the flow in the shower head, or your sprinkler system's not looking right, it doesn't cover a full pattern anymore, anything changes, that's when I would start looking for an issue that could potentially be catastrophic. What to test? Well, that depends on the issue. If it's low flow, or you're seeing surging, that very possibly could be drawdown that you need to test for, or mineralization. If you see rapid cycling, then that could be, a pressure tank issue, could be a control issue, could be power issue. And who do you call when you start to see these changes and what's going on? I would start with a licensed well contractor for troubleshooting. There are very few of these situations that we talked about today, these top 5 pump and well killers. Very few of those can be remediated by a homeowner, but we want to make everyone aware of what those are. And then also, there are a lot of times that people engage their well contractor a little later in the program, and they should be aware the earlier you engage a competent well contractor, more than likely that'll save you money over time. Don't wait until the overloads have been popping on a control box for an entire holiday weekend to call the well contractor. Leave them a message, at least get in line on their service schedule. Or if they listen to it, they may call you back and say, "Hey, turn the breaker off, let it sit for an hour, let everything cool off, see if it comes back on." If it does, everyone needs to be mindful that you may be limping to get through the weekend on the equipment you have. Certainly don't use it at full capacity until they have a chance to check it out. And then a simple monthly 15-minute check. That depends on your well system as well. If it's a residential system, I would have a monthly check program where you turn the power off to the well, open a faucet or a sink or a bathtub, and let the water drain completely out of the stored pressure and volume in the pressure tank. Then turn the well breaker back on Listen to the equipment at the wellhead or listen to the equipment in a well room and see, do you hear anything clicking on and off when it shouldn't be? Do you hear noises that you don't think are normal? Do you see things vibrating, the plumbing vibrating because there could be an issue with the pump down in the well? Do you see sparks coming off of a pressure switch where that didn't used to flash like that when it would come on? Things like that. So residential system, there are a couple of components, but look for anything out of the ordinary as you go from fully pressured up to fully drained and then back to fully pressured up. For a system that produces water into a storage tank or a pond or a lake, I think the same kind of checkout once a month is not a bad plan. Turn the breaker off, wait a few minutes, let everything settle. If there's water that is rushing back into the wellhead, you may have a faulty check valve down in the well. If you observe any loud noises or things that don't sound right when it kicks on or kicks off, that could be indication that you may have trouble on the horizon. Now, some of the big pumps and motors, we have several hundred horsepower pumps and motors, well over 1,000 feet. When those kick on, they're going to make a little noise as things bounce around inside the well. What I would look for is the sound of electricity arcing. Sounds almost like bacon frying a little bit. If you hear any sort of contactor or mechanism inside the controller clicking frequently, on, off, on, off, on, off, on, off, that's a bad sign. Um, and then just generally observe what the water looks like when it comes out. Sometimes if you have heavy mineralization in a well and you turn it off and let it set for a few minutes and then you turn it back on, you may see that well burp up, a lot of nastiness as it turned off and turned back on. Just the jostling of that equipment in the well may knock some of the mineralization around the intake of the pump loose. And this, if you have a large pump and motor and turn it off for 5 minutes and turn it back on, and you observe this thing runs really nasty water, whether it's mineral or it's sand or it looks like mud, those are all things you probably need to talk to your well contractor about as well, because it takes a lot more effort to pull and replace one of those than it does to maybe do chemical rehabs or do an early checkout in the process and give you some options as far as what may be going on. So simple 15-minute monthly checks. I would do that on residential. I would do it on commercial and larger wells within the boundaries of what the manufacturer's specs are on how often you start it. And then obviously, because we are a remote monitoring and management company, I would highly suggest putting some sort of monitoring equipment on a well. We see residential wells that have troubles with leaky irrigation system valves. We see commercial type wells that are 150 to 350 gallon a minute wells that see drawdown, and we can manage that if we can observe it before we have a failure. We've seen big industrial wells where the power was rotten that was going to the well, or they had an issue with some sort of feature on the power grid that was close to the well and no one else was seeing any troubles. And we were able to catch that before it became a full blown failure. So shamelessly, I'm going to plug Resource Monitor. There are so many of these issues that we can see and catch before it becomes a major issue. We also have alerts and alarms on our system that you can turn it on for flow conditions that you want to set parameters around, whether you want to know if your sprinkler system didn't run and you're on vacation for 2 weeks, or it's running and it's raining, or um, you have water going to livestock and you want to make sure so much water got to the livestock every day, or you want to know what the average flow rate is for a well, over a long period of time, so you can manage the conditions in the aquifer. All of those things kind of fall under our beneficial application to have remote monitoring and metering on a well. We're very, very much in tune with how to manage water assets based on the information we get from our app, because we are also in the well repair business. So with Resource Monitor, you have the DNA of a well guy or water guys that got into the business of monitoring and metering to prevent catastrophic failure and to help our customers manage their equipment, not just, hey, here's an app and you can go use it. So that's my plug for Resource Monitor. Those are the 5 things that are predominant in, or the main 5 things that will kill wells and equipment. There is my contact information. And Alex, I'm going to kick it back over to you.
Awesome. Thank you so much, Jason. Really appreciate the insight. If folks have questions, along the bottom of the Zoom screen, there should be a little button that says Q&A, where you can pop open a little chat box to ask a question or raise your hand. Um, while we wait for live folks, if they have any questions, Jason, I do have a question for you since we are getting into the colder months throughout the country, and even you showed us that Deadhead picture down in Texas in the DFW area of that ice. What are some of the ways that folks can or should be thinking about winterization or just thinking about how to protect their water wells in the cold season and as well, I guess, in the hot season, um, and maybe ways that they should not only do it themselves, probably not themselves, but also what they should be asking their contractors and what they should be looking for to make sure they don't have a 2.5 foot long wedge of ice sticking out of their water
Sure.
well.
Yeah. So, winterization means different things to different people. Down here in Texas, we have a couple of months out of the year where we'll have intermittent freezes and it can get cold enough to damage equipment. In a lot of places, they don't have that. They don't have the option to use their well through the entire year unless it is configured to do so with like a subsurface completion called a pitless adapter, or it's inside of a well room where they control the environment around the well and keep it above freezing. But there's kind of two options. You either have to keep it warm enough for it to keep water moving and not create that ice plug that we saw in the slide, or you take it out of service and drain the water out of the plumbing and equipment so that you don't end up with damage. We have folks that do both. I mean, at my house, I have a well and I don't have the option to shut it off because it's the only source of water we have for our house. And so we have to keep the wellhead warm enough. And then we have all of our well equipment inside of a building where we control the environment enough to keep it warm. Things that people generally forget to do when they see the freeze warnings come on this time of year. They take care of their plants and their pets and they think about the water faucets on the side of the house, but they forget about the well that's in the well house out in front of the house. Um, we see that probably, I don't know, conservatively, we probably see 90 or 100 freeze damage calls during the wintertime. And then in the springtime, when people are ready to start using wells for irrigation again that they didn't use all winter, we have hundreds of freeze damage calls. And that can be anything from a cracked pipe or a broken fitting or a frozen ball valve to they froze the entire system. It blew the pump up. But before the pump blew up, it melted the end of the pipe and shot itself to the bottom of the well. Now we've got a pretty good mess to deal with. So we've seen all of the above. So drain it or keep it warm. And those are kind of your only two options for winterization. For heat, the reverse is a little bit kind of the program. Heat generally will affect controllers, electronics, things like that. They have a high threshold, or they have a threshold for a high temperature, I should say. And then also rapid starts or too many starts generating heat in a well house or a confined environment when it does get hot. Sometimes pumps and motors don't like that for operation above ground, like a booster pump or a pump station. If it's too enclosed and it's not able to dissipate some heat, you'll run into that issue during the summertime.
Got it.
So
Um, Jason, one other question. What for the average well owner maybe who has it, for their local business or for their home, what would you say is the number one problem that you all experience, and how would you advise that an individual well owner address that problem proactively, whether it be, a visual monitoring or, some sort of alert or notification? I mean, how can folks basically ensure that that most common problem doesn't happen to them?
it'd be hard for me to say that there's one most prevalent common problem. Um, you know, you, in a well system, you're talking about a pump and a motor. You've got screens or perforations in the well where the water flows in. You've got a pressure tank of some kind or a regulating system. You have controls that turn it on and off, and those controls may be a start contactor. It may be some capacitors to fire the pump and motor and get it started from a dead stop. Could be some electronics. So it's hard to say that there's any one, there's one common failure on well equipment and wells. What I would say though is proactive maintenance is generally not at the forefront of most people's mind when they talk about their well system. They turn it on and water comes out, and they don't think about it until the water doesn't come out, and then it's a problem. If
Yeah, then
you,
it's the only thing you think about, right?
yeah, for a little bit,
It's not a big deal when you're, taking a shower and filling up your water pitcher, but as soon as the water's not there, nothing else matters until that water's back.
it's a big problem. Yeah. So, probably the one thing I would say, the number one thing I would tell people is maintain your stuff. You change the oil in your car, you rotate the tires, you do some maintenance on a vehicle. Some water wells that we're working on right now, the pumping equipment costs more than a vehicle. So why not spend a little time and maintain that? I would probably wager, and I may throw this out there when we are teaching the CE classes at the national convention here in a couple months. If you put a well contractor on site at a water well once or twice a year, preferably twice a year before the main demand season and after the main demand season, if you put a contractor on site to maintain that well, check it out twice a year, the long-term service call costs versus the preemptive failures that they can prevent, or the failures that they can preemptively prevent, I think you'd be dollars ahead paying a good contractor to come out and check your system out once or twice a year. The second thing that I would say, and again, I'm going to plug RM. The second thing I would say is you can't manage what's going on with that well unless you're monitoring it. And just looking at the water coming out the end of the pipe, or hey, everything's fine. I didn't notice that we didn't, we were having issues until it was a problem. Monitor what's going on. Use our equipment on the monitoring side that's rather affordable for actually for all users, but I mean homeowners can get down to where it costs less than what they're spending on coffee 4 days a week. So you know,
Yep.
we can prevent a lot of things. We can give insight to things that are happening. It's a lot easier to make an adjustment in the wintertime. Maybe you have to resize some of your sprinkler zones around your home. It's easier to do that in the springtime when you know your well was drawing down or near drawdown in the winter or in the fall when you shut it off, rather than get to the middle of July and now you can't get a irrigator on the phone because they're busy as they can be and your yard's trying to die, or maybe you've got issues with mineralization and you can proactively knock that out along the way instead of waiting until a complete failure and then you're trying to undo months or years worth of mineral incrustation in one treatment.
Hmm.
So number one, get
Jason, how much does it cost for a service call typically for that well contractor? Let's do the math. Is it what, 200, $250 to have them come out and perform some basic maintenance?
I think let's just say 150 roughly.
Okay. So they
Now
come
for
out twice
folks,
a year,
yeah.
and it's $300 a year in maintenance. And then what's the average residential pump replacement job
Oh,
cost?
I mean, it's kind of like the cost of a service call. I mean, what I was going to say is average across the US is probably 150. It may be higher depending on how far a contractor has to travel. But kind of similarly, it depends on how deep the well is. But I would say on a minimum, down on the lower end, when you get into the lower horsepower pumps and motors at say 200 feet, you're still talking a couple $1,000 at an absolute minimum. We have some pumps and motors we work on for residences that have 800-foot deep wells that are in the tens of thousands for a replacement on the system. So
So, like, let's say it's even $6,000 to replace that low end system versus the $300 a year to maintain it. You're talking about the trade-off of 20 years of maintenance for that the equivalent of 20 years of maintenance for that one $6,000 job. And then over that 20 years, you got water. It's not that big problem that we're talking about. So I think yeah, it's absolutely a no-brainer. You don't want to buy a new car every year in the same way that definitely don't want to buy a new water well every
well,
year,
and
right? And
two,
there's at least with a car you can resell it. With a water well, you're not reselling it. It's your production.
The other thing that happens too in a lot of cases, and let's just take your $6,000 repair on a residential system. Let's say that a pressure tank was starting to go bad and it got to where there was no stored pressure and volume in the tank. It caused the well to rapid cycle, which is going to burn the points on the pressure switch. It's going to overheat the start capacitors in the control box, and it's going to burn the pump and motor up. The one part of the system that failed then cascaded into every other part of it. So new pump, new motor, new control box, new pressure switch, new pressure tank. Pretty much that's everything but the plumbing and the drop pipe and the well. So when you see things starting to happen along the way, every 6 months, if you had a well contractor out there, you could probably catch a pressure tank going bad before it actually had the catastrophic failure. Same with a well pump. You're going to start to see the amp draw go up whenever it should be going down. If you do a proper flow test and a stress test on it, you can check the integrity of the insulation in a motor from the surface if you have the right equipment. So it's not just it's going to run fine and everything's going to be perfect until one day and then it blows up completely. I mean, we can see a lot of things happening along the way. And quite frankly, if someone knows that they're going to need to replace a pump in the next 3 to 6 months or a year, financially they can prepare for that too. So it's not just the fact of staying in water and preventing the big ugly. Sometimes it's, hey, you got this and it's working in the wrong direction. Start saving up for a $4,000 or $5,000 pump job or whatever the cost may be to replace that equipment. And it's not so much of a
Hmm.
shock. Again, another benefit to working with a contractor, knowing where you are. If you use monitoring equipment like ours, you can see that happening over time and it's not such a big surprise too.